Welcome to Unit 1, Lesson 13, More Standard Deviation. If you remember, in Lesson 12, we started talking about standard deviation, and in this lesson, we're just going to continue on. Our learning goal for today is to continue to interpret standard deviation. Our learning target today. This is the thing you should be looking at as we do the practice problems. By the end of the lesson, you should feel comfortable making the statement, I can use standard deviation to say something about a situation. If at the end of the lesson you do feel comfortable making that statement, then you're right where you need to be. If at the end of the lesson you are not comfortable making that statement, then please use class time to ask for further clarification so that you are set up for success moving forward. We have a vocabulary term, standard deviation. This is a measure of the variability or spread of a distribution calculated by a method similar to the method for calculating the MAD, or mean absolute deviation. The exact method is studied in more advanced courses. Our next vocabulary term is statistic. This is a quantity that is calculated from sample data such as mean, median, or MAD, mean absolute deviation. As we begin our practice problems, the first one says, 3 drivers competed in the same 15 drag races. The mean and standard deviation of the race times for each of the drivers are given. Driver A had a mean race time of 4.01 seconds and a standard deviation of 0.05 seconds. Driver B had a mean race time of 3.96 seconds and a standard deviation of 0.12 seconds. Driver C had a mean race time of 3.99 seconds and a standard deviation of 0.19 seconds. Which driver had the fastest typical time? So the word that we want to key in on here is typical. And if we want the typical race time, then we want the mean. So that is what we're going to compare on each of the drivers. Because this is a race, lowest time is fastest. So if I want the fastest typical race time, I want the smallest mean, and that would be driver B, 3.96 seconds. Number 2, which driver's race times were the most variable? So our key term here is variable, so we're comparing the standard deviation. And the bigger the standard deviation is, the more varied it is. So that would be driver C, 0.19 seconds. And number 3, which driver do you predict will win the next drag race? Support your prediction using the mean and standard deviation. So, if I have a standard deviation of 0.05 and a mean of 4.01, that means driver A will be somewhere between 3.96 to 4.06. Driver B, standard deviation of 0.12 and a mean of 3.96, will be somewhere between 3.84 to 4.08, and driver C, with a standard deviation of 0.19 and a mean of 3.99, will finish somewhere between 3.80 to 4.18. So there's a lot of different ways to argue this. You might argue that driver C is more likely to win because they have the fastest time, but they also have the slowest time. You might go with consistency and say that driver A is very consistently between 3.96 and 4.06, so his worst is the best, and his best is somewhere in the middle of the other two. So you can answer this any way you want. I would predict the more consistent driver to win. So I'm going to choose driver A. Because they're consistent. If you have any questions about how to identify and compare the typical race value, being the mean, and the most variable, being the standard deviation, or how to make interpretations for yourself, please use class time to ask for further clarification so you can be set up for success moving forward. The widths in millimeters of fabric produced at a ribbon factory are collected. The mean is approximately 23 millimeters, and the standard deviation is approximately 0.06 millimeters. Interpret the mean and standard deviation in the context of the problem. So we are talking about the width of ribbons. So the mean tells us ribbons are typically 23 millimeters wide. The standard deviation tells us the ribbons can be as skinny as we would subtract 0.06 from 23, and that would be 22.94 millimeters. And as wide as we would add 0.06 millimeters to 23, and we would get 23.06 millimeters. So the mean is telling you how wide the typical ribbon is, and the standard deviation is telling you how varied the results could be. The majority of these ribbons, even though typically they are 23 millimeters, a large majority of them are actually somewhere between 22.94 millimeters and 23.06 millimeters. If you have any questions about this practice problem, please use class time now to ask for further clarification so that you are set up for success moving forward. Our last practice problem says select all the statements that are true about standard deviation. So first, notice that this says all. That means there can be more than one correct answer. Also notice that we are talking about the standard deviation. So as we go through here, notice A says it is a measure of center, and B says it is a measure of variability. The standard deviation tells you how spread out your results are. So it is a measure of variability, not a measure of center. C says it is the same as the MAD, or mean absolute deviation. While it is similar to the mean absolute deviation, it is not the same. They are slightly different. And choices D and E are both about how it is calculated. D says it is calculated using the mean, and E says it is calculated using the median. The standard deviation is always calculated using the mean. So the mean is always paired with the mean absolute deviation or the standard deviation. Median will be paired with the interquartile range. If you have any questions about any of these practice problems, please use class time to ask for further clarification so that you are set up for success moving forward.